Hello and welcome to another episode of EnVisioneering Exchange, the podcast where industry leaders discuss the most important topics in HVACR. I'm your host, John Sheff, Danfoss's Director of Public and Industry Affairs. And you can subscribe to our show on Apple Podcasts, Spotify, SoundCloud, or wherever it is you get your podcasts. In today's show, we're going to do a deep dive into a district energy project. And if you haven't listened to our last episode, you might want to go back and listen to episode 7, where today's guest, Jeff Flannery, was also on the show talking about district energy in general. And he laid down a really great foundation on the topic. Now, you can definitely listen to this show without listening to that one, but you'll have a lot of great information if you listen to both. So I'd like to welcome back our guest, Jeff Flannery. He's Danfoss's Senior Business Development Manager in charge of district energy in North America. Jeff, thanks for being back with us.
Well, thanks a lot for having me, John. I appreciate being here. I'm looking forward to another good episode, and got a great customer here to talk about in Sheridan College. So, let's get started with that.
Great. Yeah, let's dive in. Why don't you tell us a little bit about Sheridan College, where it's located, and what type of institution it is, and a little bit about the project.
Okay, well, Sheridan College is in Ontario, Canada, and they were formed in about 1967. Today, they've got 23,000 full-time students and another 17,000 continuing education students, and they have some international reach with around 8,000 international students enrolled. They're operating from 3 campuses, and those are in the communities of Oakville, Brampton, and Mississauga, and all those communities are on the west side of the Greater Toronto area.
So that's really interesting. But before we get too much further into the actual project, Jeff, why don't you give us a little bit of background and a recap of what we discussed in the previous episode on district energy in general?
Yeah, that's probably a good idea, John. Let's review that a little bit from our last episode. So district energy refers to heating or cooling systems for multiple co-located buildings that have an interconnecting system of insulated pipes for delivery of thermal energy. That energy gets generated at a nearby central plant and distributed to the connected buildings by steam, hot water, chilled water, through that insulated pipe network. And within each building, the energy gets transferred to the building's heating or cooling system by an energy transfer station. So the common thread here is that the thermal energy gets generated centrally and distributed to the buildings rather than each building generating its own heating or cooling energy.
So what was Sheridan College's primary challenge with its existing heating system?
We'll get into that in a minute, but I think this might be a good time to expand a little bit on what Sheridan College is committed to, because their commitments go well beyond addressing the building heating and cooling systems. They've really committed to a robust campus-wide sustainability program that extends into the teaching and learning, waste management, operations, and transportation topics on campus. The building energy retrofits is an important part, but it's certainly not the only part of their sustainability efforts. This multi-layered approach is one of the ways their sustainability director, Herb Sinnock, has been able to build support for initiatives on campus. I really think when a wider and inclusive view of energy and sustainability gets embraced, the support for each element of the program seems to improve. And I think Herb has been really effective in embracing that kind of inclusive view. Sheridan is also working with the towns and cities where they operate, as well as other municipalities on community energy plans to reduce greenhouse gas emissions from building use and transportation. So now back to their primary challenges with their earlier existing heating systems. Most of the work Danfoss has helped them with to date has been at their Oakville campus. So I'll comment on what I've been exposed to there. The Oakville campus has around 9,500 students. There are about a dozen buildings or major additions to buildings on campus. And like many higher education campuses around North America, there's a collection of aging buildings on campus mixed with a few newer ones. The campus had 6 boiler plants spread across the campus, providing heat to each space on campus. This configuration led to inefficient distribution of heating and cooling, boilers and chillers that were too large relative to the loads for the buildings they served, particularly when the buildings were in partial load conditions, and this has just wasted a great deal of energy. So it's clearly a campus that grew over time, and that sporadic growth led to some compromises in the use of heating and cooling equipment across the campus. Additionally, the operations team had really limited data on the buildings because they were not independently metered. I'd heard from Catherine Reines, their project and program manager for sustainable energy systems, that they'd undertaken a program of introducing meters to better baseline the energy use around campus. And I think that's a common and essential first step towards making improvements. So a little synopsis of where they came from.
Yeah, I mean, I think it's super interesting that it's a pretty big project, but it fits into the larger dynamic and larger plan they have for sustainability on campus, and how Herb is getting buy-in from all the parties involved to really remake the campus in a very sustainable image. So very cool stuff there. How did you first get involved with this project, Jeff?
Well, I'd met Catherine Reines, who I mentioned before, and Herb Sinnock, the director of sustainability at Sheridan College, through a few industry events. The Sheridan team had spoken on stage about their CHP-based district energy project planning during its really early phases. And I was at some of the same events speaking about packaged energy transfer stations, or ETS, from Danfoss, and some of the unique approaches we had to the integration of domestic hot water production on our equipment. And we had some good conversations around both of our topics when we met. The Sheridan College team was searching for capable partners for this European-style district heating network. And at the same time, I was working to introduce the North American market to what Danfoss was capable of with prepackaged factory-built energy transfer stations. So it was clear to me from the beginning, and I think probably Herb and Katie, that we were going to be great partners. And I was just excited to learn more about what their goals were.
Yeah, I mean, it's always fun to get a customer and a client and really a partner who has such ambition. But I think everybody is familiar with plans starting out one way and then going in a different direction when you kind of meet reality. What did Sheridan initially want for this campus wide system here?
My brief synopsis would be they were looking for a new district energy system with a single central plant. They wanted to serve the energy needs of all the buildings on campus, and that's what they proposed. It included construction of a new central energy plant located within one of the buildings, and that's complete. The new plant includes combined heat and power technology, or CHP. The CHP plant produces electricity on campus, and it's fueled by natural gas. The waste heat from the production of electricity is captured and concentrated in a distribution pipe network that distributes water around 212 degrees Fahrenheit. And Sheridan College wanted to improve the DeltaT in their heating network as well, from around 20 degrees Fahrenheit, which they had with their boiler plants, to something more like 50 degrees Fahrenheit with their new district energy system. And this was going to save a considerable amount of pump energy. So at Danfoss, we could help them achieve that high DeltaT with our ETS technology. And this is where we really found our first common ground.
Yeah, I could talk DeltaT all day, but that's a rabbit hole I don't think we should go down right now. But, it's interesting. I think a lot of people hear that natural gas is used to generate the electricity, and they're thinking, wow, that's not the most sustainable or green. Shouldn't we be using something more like renewables? But I think because the waste heat is captured and you're getting the DeltaT up, so it means the system is operating at its peak efficiency. This is a really sustainable and really efficient system that you're talking about, even though it's using natural gas to generate the electricity.
Yeah, we're using the waste heat from electricity generation to heat buildings. So, I mean, I don't describe that as waste anymore. I describe that as reuse.
Yeah, definitely a renewable resource. Um, so, Jeff, this was the first campus wide district energy project in North America. Was there anything unusual about it or challenges that were not apparent from the start?
Well, Danfoss has been doing other district energy work in North America, including the fabrication of prepackaged energy transfer stations. But the Sheridan College experience was kind of new and unique for us in North America in two ways. As you mentioned, this would be the first time we deployed a campus-wide heating solution, and it's important to note that we were going to be doing that in a single construction season. And second, this would be the first time we fabricated all of the pipe networks for those energy transfer stations here in North America. Previously, we'd been doing some of the fabrication offshore and then importing completed goods using the factory resources that we have within Danfoss in our European factories. Here in North America, the heat control module, which is something we embed inside the controller, was also going to be a little bit unique for the experience of Sheridan College. So we had some new firmware solutions to deploy into the controllers to pull this off for Sheridan College. So that was a little bit unique as well.
Yeah, so I think this was actually a really big step for us in district energy in North America, having the supply chain here to doing it all in one season. A lot of really great stuff going on for this project. Can you describe the timeline on this project from inception to final installation?
Well, hey, a discussion of the entire project timeline would be much better handled by the Sheridan College team and include a discussion of the construction of the central plant, raising the capital money, et cetera. And that's probably better handled by them. But I can address the portion that involved the energy transfer stations from Danfoss. And that experience started when the Sheridan College team pre-qualified Danfoss as a supplier. That was back in November 2016. And at that time, they were still working on burying pipes in the ground. In September 2018, the team requested competitive bids for the energy transfer stations needed at their Oakville campus, and we learned that there would be 10 at that time. And in November 2018, Danfoss was awarded the work. So ETS deliveries began about 4 months later. That was March 2019, and they were completed in August that year. At the same time, the Sheridan College team was hiring and supervising contracting teams for demolition work and extending the pre-insulated pipe networks into the mechanical rooms. And delay in the completion of some of that contracting work meant the new heating equipment from Danfoss wouldn't get installed until late October 2019 when the heating season was imminent. Remember, we're talking about a location that's on the west side of the Toronto area. So when I arrived there in October, I saw students walking in the halls with their jackets on, and there was some nervousness about the fact that we needed to get the heat turned on. Several of the buildings were without primary sources of heat at that time due to the demolition work, and overnight temperatures were dropping towards the freezing mark. But anyways, we were ready to start the new heating system for the first time there in late October, and yeah, that's how I recall it getting started. We turned them on in late October and heated the buildings the same day.
Yeah, even late October up in Ontario is pretty chilly. I'm glad you got it done then because, going through a heating season without heat in these buildings caused major problems for the college.
Well, there was nervousness on the part of Herb at the time, and I know he was pressing Katie to, have a backup plan, but she had a lot of confidence in what we were doing. She knew that we had, tested all of this equipment in the factory environment before we delivered it to her in Sheridan College. So, we banked on that, and it turned out to be exactly true. I mean, we promised that the stuff would be ready to heat upon turning it on, and that's what it did.
Okay, good execution. So is this timeline typical of district energy projects?
Well, certainly district energy projects can span multiple construction seasons, and I think that's quite common. The Sheridan College project, probably best described as relatively small in terms of district energy projects worldwide. But it's pretty impressive that this mid-sized community college was able to complete the project using primarily their own resources for project planning and project management. And they did it by identifying and hiring capable partners for different parts of the project scope. At Danfoss, we're just pleased to have been one of those trusted partners. There's no doubt the project could have been accelerated, but the Sheridan College team took on the work at a pace that was comfortable for them to manage. So, yeah, I mean, I look back on my experience with them. It was about 3 years from inception to installation of the heat transfer equipment. But they were at it for 5 years or more themselves.
And yeah, they're a really impressive team. Herb actually came and spoke at our HR press breakfast this year on the project and was really impressive.
Yeah, he's got a lot of command of the topic, and he's got a lot of enthusiasm for it too. So
For sure.
he's great.
So, like you said, this project was going on for more than 3 years, 5 years. Is a long project. How does Danfoss fit into the larger scope of this project?
Well, the Danfoss team had responsibility for designing and fabricating the energy transfer equipment for every building on campus. And we heavily customized the equipment to fit into some really tight mechanical room spaces and to move through halls, doorways, elevators en route to those mechanical rooms. And this is a service that I know for sure Herb and Katie at Sheridan College really appreciated from us because they were asking to get this equipment into some extraordinarily tight spaces. And in some cases, they wanted to move it into those spaces prior to the demolition of the steam work. that was in place. So we were moving around existing assets to get our equipment into final resting positions for the heating season. So there was nothing unique about what we did. It was all customized pipe work to minimize the work on campus. We worked really closely with the Sheridan team on the site surveys in order to make that possible. The whole goal of this was to optimize the connection of our equipment to the pipe networks within their buildings. And really, this was one of the most enjoyable parts of the whole project for me, because I was really impressed that Sheridan College was willing to involve junior members of the team, some of which were students in the process. And I think it really speaks to the hands-on approach to learning they have at Sheridan College. Our collective goal was avoiding excess labor costs in the field, and we succeeded in getting that done.
So I think that's one really cool aspect about this project is that when Herb spoke at our press breakfast, he did mention that this is still an ongoing learning opportunity at Sheridan College, and that students can visit the project, can get their hands on it, and learn about how the campus is heated through this project. And it's really awesome that students were also involved in the construction. So that's pretty cool. You mentioned that these Danfoss energy transfer stations were fabricated off-site and then brought into some pretty tight spaces. Talk a little bit about what the advantages of using these kind of prefab ETSs versus traditional on-site assembly that has been used in North America on energy transfer stations.
John, I'm really glad you asked that question. I think it's one of the most important ones for our listeners to have a simple answer to. In many ways, the Sheridan College experience highlights the value proposition Danfoss are offering in North America with these pre-engineered energy transfer stations. At the end of the day, our customers at Sheridan College were freed from excessive specification writing to describe an ETS. We demystified that task for them. The only thing they needed to provide us with were the space heating and domestic hot water requirements for their buildings, basically the loads for the buildings. And Catherine Reines, who we've talked about a couple of times now, had been collecting some meter data. So she just formatted that in an Excel spreadsheet and sent it to me. And basically, that was the task for her. The balance of the design work, including optimization to fit in the existing mechanical rooms, was all trusted to Danfoss. They did not need to hire and supervise contractors on site to stick build their energy transfer stations. They confidently proceeded with their other construction tasks right through to the start of the heating season. They could be confident that our pre-engineered and tested stations would heat their buildings upon first start, and they did. And they would also benefit from simple onboard ETS controls that allow them to optimize the heating performance of both their CHP plant and their buildings over the long term. So they're empowered with a lot more data now than they had before.
And yeah, it just seems like they offloaded a lot of the risk onto Danfoss, who does this stuff professionally. It seems like if you have stick-built ETSs, if you have 10 transfer stations, you could have 10 different transfer stations all being built separately. So a lot of that risk is taken off of the customer's hands, and Danfoss deals with it effectively. So I think a lot of value there from our side. So now that you've kind of taken us through the project, taken us through what Danfoss did, explain the differences in how the system's operating now versus how their heating system was operating before.
Okay, well, that's a big question, and I'm sure I can't answer every aspect of it, but I think I can offer a simple response that probably will resonate with our listeners. First, the Sheridan team is now operating a single central plant for heating their entire campus. That's in contrast to 6 aging boiler plants that they were responsible for previously. Second, they're empowered with tremendously more data on the performance of their central plant. And because of the technology built into the energy transfer stations from Danfoss, they've got a tremendous amount of easily accessible data on the heating performance of each building on campus, too. The controls on the Danfoss energy transfer stations allow them to quickly make incremental adjustments to both flow and temperature on both sides of the heat exchangers, and that empowers them to save time, money, and energy over the long haul. They've got a really valuable new set of tools in their toolbox. Lastly, I'd say they simply enjoy having new equipment that they can better control. it gives them tools for learning in a learning environment. And I know for sure that they appreciate that.
Yeah, it sounds like things are just operating a whole lot more smoothly. They got a lot more data, and they're able to control the heating system a lot better. And it makes for a lot more comfortable winters up there in Ontario, I'm sure.
Yeah, well, John, they've just been through their first heating season with the equipment in play. So I'm sure that they're doing a lot of learning right now and probably beginning to pour over the data that they collected over the past several months, and probably getting excited for next winter to put it into play.
Very exciting stuff. Speaking of learnings, they had a lot of learnings. I'm sure you had a lot of learnings, considering this was the first campus-wide project in North America for Danfoss. What did you learn?
Yeah, well, first I would say I learned not to sweat the small stuff. The primary lesson for the Danfoss team, I would have to say, is around the topic of improving our schedule performance in North America. I'm really confident we can improve our lead time for packaged energy transfer stations in North America, and that's an area we're actively working on now. So, again, this was the first time we fabricated everything here in North America, and that really was the initial new trick, and resulted in a lot of opportunities for learning.
Yeah. So where does the project stand now? Are there more phases? Is it complete? You said they're going into their first heating season. Where is Sheridan College going now?
Well, there are additional phases to the work at Sheridan College's 3 campuses. In fact, we have some additional energy transfer work in process for Sheridan's Davis campus, and I'm really looking forward to getting that completed. It's kind of exciting because it includes a large energy transfer station on the heating side that's going to incorporate multiple independent space heating loops. So it's going to be distributing 2 different temperatures, one to an air handling unit and one to a radiant circuit. So those 2 temperatures needed to be different, but we're doing that with a single energy transfer station and a mixing loop. That required us to write some new software for our controller. And then in addition to that, it's got instantaneous domestic hot water production on that same energy transfer station skid. So we were really trying to make a very densely packaged product for them to fit into an existing equipment room on the 3rd floor. And soon we'll be craning that up 3 floors and through an open window to get it in place and commissioned. There were some work slowdowns due to the COVID-19 responses around North America that have impacted that project. So it's especially important to me to get that done. It's, for me, a professional benchmark for knowing the world's putting COVID-19 in the rearview mirror. So looking forward to getting back up there and getting that one fired up.
Yeah, for sure. So let's take a step back for a minute from Sheridan College and just talk very quickly about how you see the market for district energy in North America going forward from 2020 and on.
Well, I'm excited what I see happening in the market. There's a market that's continuing to grow, and it's getting quite a bit of attention. The higher education market is definitely a hot spot, and the Danfoss team is working together with multiple institutions to bring their plans for less energy use on campus to reality. I enjoy that work a great deal. Steam to hot water conversion is part of that equation, but it's not the whole story. Unfortunately, energy waste on a grand scale continues to plague the people across the world, and it's no different here in North America. Once you open your eyes to it, it's seen just about everywhere. And on university campuses, I think they have a wider view of this problem than maybe you see in other market niches. District energy has the potential to address waste on a bigger scale, and that makes it exciting. At Danfoss, we're really fortunate to be aligned with peers contributing to district energy solutions every day. When we get an opportunity to do that on a college campus, we're making a real difference. I find that fun, and in the Sheridan College team, I found like-minded professionals. So we'll get started on another college campus soon, and I'd like to come back and chat with you about that in another episode.
That would be awesome, and I really appreciate it, Jeff, not just for this episode, but for the previous one too, and really doing a deep dive into district energy and the Sheridan College project. So that's it for this episode of EnVisioneering Exchange. I'd like to thank my guest, Jeff Flannery, for joining us again. And don't forget to subscribe to EnVisioneering Exchange on Apple Podcasts, Spotify, SoundCloud, or wherever it is you listen to your podcast. Lastly, if you enjoyed this episode, don't forget to rate, review, and share with your network. It really helps us out. Thanks again for listening. I'm John Sheff, Director of Public and Industry Affairs at Danfoss, and we'll talk to you next time.